Using a simple pendulum, plot LT and LT square graphs and use it to find the effective length of a second's pendulum. An ideal simple pendulum consists of a heavy point mass called bob tied to one end of a perfectly inextensible, flexible and weightless string. In practice, we make it by tying a metallic spherical bob to a fine cotton stitching thread. The distance between the point of suspension of the pendulum and its center of gravity, CG, which is the CG of the bob, is called the length of the simple pendulum. It is represented using the alphabet L.
Ma'am, how can we find the effective length of a second's pendulum?
The time period T of a simple pendulum of length L is given by T is equal to 2 pi under root L by G, where G is the acceleration due to gravity. On squaring both sides of this equation, we have T square is equal to 4 pi square L by G, or T square directly proportional to L. Therefore, if we plot a graph between L and T square, it will be a straight line. Let's do an experiment by using a simple pendulum, plot LT and LT square graphs and use it to find the effective length of a second's pendulum. Our aim here is, by using a simple pendulum, plot LT and LT square graphs and use it to find the effective length of a second's pendulum. The materials required are a clamp with stand, a split cork, thread bob, vernier calipers, stopwatch, meter scale and a piece of chalk. Procedure. First of all, find the vernier constant and zero error of the vernier calipers. Find the mean diameter of the bob using vernier calipers and then mean radius of the bob. Mark points M1, M2, M3 on the thread by ink at distances 80 cm, 90 cm, 100 cm, 110 cm, 120 cm, 130 cm respectively from the center of gravity of the bob. Now tie the hook of the bob to the thread about 200 cm long and other end of the thread is passed through the two slit parts of a cork with the thread coming out just from 80 cm mark. Tighten the two half cork pieces between the clamp. Fix the clamp in a stand and place the stand on the table in such a way so that the bob remains about 2 cm above the ground. Mark a point A just below the position of the bob and draw a straight line BC of length 10 cm having point A at its center. Over this line, the bob will oscillate. Find the least count and zero error of the stopwatch and bring its hands at zero position. Displace the bob from its mean position O up to a distance of 5 cm and then release it gently so that the bob oscillates about its mean position O over the line BC. Make sure that the bob does not spin about its own axis while oscillating. Observations. Mean radius of the bob R is equal to D by 2 is equal to 5 cm. Length of hook of the bob H is equal to 200 cm. Standard value of G is equal to 980 centimeters seconds raised to the power minus 2. Least count of stopwatch is equal to x seconds. Zero error of stopwatch is equal to x seconds. Zero correction of stopwatch is equal to x seconds. Table for length and time period. Length from top of the bob to the point of suspension L centimeter. Effective length L is equal to L plus R centimeter. 1, 130, 2, 120, 3, 110, 4, 100, 5, 90, 6, 80. Time for 20 oscillations. T seconds. T1 seconds. T2 seconds. Mean T seconds. Time period T is equal to T by 20 seconds. T square, second square. L by T square, centimeter per second square. Result. The graph between L and T is a parabola. The graph between L and T square is a straight line. From the graph, the length of the seconds pendulum is 100 centimeter.
Thank you, ma'am, for this knowledgeable experiment.